Hello, and welcome to this live webcast, Fibre Channel Zoning Fundamentals, All You Need to Know, brought to you by the FCIA, the Fibre Channel Industry Association. Before we start, just a few housekeeping notes. For anyone interested in downloading a copy of today's presentation, it's available in the Attachment tab at the bottom of your display console. You're also welcome to submit questions during the presentations. We'll get to as many as possible near the end. And we encourage you to rate this presentation and provide us with feedback on your way out. So let's get started. We're very fortunate today to have an esteemed group of experts to cover the topic of fiber channel zoning. Our speakers are AJ Casamento, Principal R&D Engineer from Broadcom, Rupin Mohan, Director R&D CTO SAN at HPE, and also a member of the FCIA Board of Directors, Craig Carlson, Senior Technologist at Marvell and an FCIA board member, Kiran Ranabhor, Product Manager at Cisco for Cisco MDS, and Kiran is also a member of the FCIA Board of Directors. For those not familiar with the FCIA, it is a mutual benefit, nonprofit, international organization of manufacturers, system integrators, developers, vendors, industry professionals, and end users. The FCIA has been promoting Fibre Channel for more than 25 years. The organization is comprised of industry-leading member companies, and more than 142 million Fibre Channel ports have shipped since 2001. So today's agenda will be covering what is zoning, different types of zones, how zoning works, and using zoning. And we'll start with AJ Casamento, who will explain what is zoning.
Thanks, Diane. And I wanted to just give you a quick overview, folks, of zoning. Zoning is a mechanism for partitioning a storage area network, right? And you can also think of it in terms of a little bit of security in that same environment. So the zoning standards got added into Fibre Channel in the mid-90s, and really in 1998 was the first time that the switch providers at the time began to implement zoning. And it was an interesting scenario because it came about over a period of time. And part of that had to do with the fact that not all operating systems treat storage the same way. And so as funny as it may seem to people today, back then, one of the challenges that we had was as you started mixing Windows, and in particular Windows NT, into these storage area networks, we had a challenge where Windows was effectively the 2-year-old child in the house. Anything it could see was mine, mine, mine. And if it could see it and reach it with its crayon, it would write a volume label on it, which wasn't really good for other operating systems. And so the ability to isolate, isolation of functional groups also became a focus, isolation of the operating systems, as I mentioned, protocols as well. So some of the very early deployments for Fibre Channel were actually IP over Fibre Channel. So IP over Fibre Channel and FCP over Fibre Channel had to be isolated from each other. And then storage sometimes, and server vendors sometimes needed isolation as well. So, that was really kind of the scenario that it came down to. And today, it's the standard deployment for us, but it's always been a distributed fabric service. This is a little different than what you think of for other networking types. In our environment, every switch, it doesn't matter which vendor, every switch has an image of the zoning environment and of the name server environment, as opposed to having a couple of isolated platforms that are attached to the network that are supplying that data. And so it makes it extremely resilient. Even if something happens to one of the elements, everybody still knows what's going on. And it's a very explicit access mechanism. And it may seem a little overkill, a little granular to people sometimes, but sort of keep in mind that when you interfere with an application platform's access to its storage, to its data, that result is considerably different than just refreshing a browser, right? That pretty much comes down to what color is your favorite screen, because you're going to freeze the system. So, where are we now? Well, zoning is the default mechanism for SAN deployments. It allows partitioning and pretty routinely single initiator, single target zoning had been the standard. And, Rupin's going to talk to you about some shifts in that. Kiran's going to talk to you a little bit about some deployments around it as well. But the baseline is that it allows for isolating a server to its storage, right? And very granular mechanism that is hardware enforced. And so to be very clear, regardless of what kinds of zones we talk about, the enforcement for the switch vendors that are in the market today is in silicon on the port. And so you can sort of think about it a little like a MACsec kind of, hardware enforced MACsec kind of implementation. It's not an exact map to that, but that's sort of something that most Ethernet folks would understand as a corollary. And so it provides you that very, very granular enforcement, and you're either a member of the zone or you're not a member of the zone. And if you're not a member of the zone, you can hammer at that all day long and you won't get any access. So from a security standpoint, it's extremely good. It also isolates noise, and so much like the origin of VLANs was really to isolate broadcast traffic, because anybody who's ever had responsibility for small children knows that being tapped on the shoulder every 3 seconds with mom is not something you want, right? So isolation of broadcast traffic, or registered state change notification traffic, which is what RSCN stands for, is isolated within the zone as well. And so it gets to cut down some of the broadcast traffic that's involved. So just sort of give you an overview of what's going on here, because Rupin's going to walk you through actual zone types, and Craig's going to tell you how it works, and then Kiran's going to show you some best practices for it. But it's really this concept of isolating to individual environments, right? So the fabric basically provides a set of services out to the environment. The zone environment is one of those things. You can have multiple zone configurations with one of them active at a time. But you can also have zones that overlap, and pretty routinely storage arrays end up in an overlap sort of scenario, because they're a shared resource between multiple platforms. And I want to also make the point, and I think Kiran will talk about it too, that as we talk about non-volatile memory express, or FCNVMe2 as the standard is, non-volatile memory express, or NVMe, is just another protocol running on top of Fibre Channel. It doesn't change your management. There's no magic to it in that sense. There's no, you don't have to go get a master's degree to handle it. It's the normal Fibre Channel zoning you already know, right? So there's no massive change to that. So really think about it in terms of visibility, security, and access, and that's really what we're doing with the zone configurations, right? And so when you think about it for deployments, whether you do it as based on the worldwide name of the devices, right, which sometimes gets referred to as soft, or based on the ports on the switches, which is sometimes referred to as hard zoning, keeping in mind that everything is still enforced in silicon. Deployment is always driven through fabric configuration, right? That source can be management tools. You can script against the switches. Rupin's going to explain to you one of my favorites that I wish more and more people would do, which is target driven for those environments, and he'll walk you through that. But think about it from an automation standpoint. Please always think about the idea of aliasing in the environments as well, right? Because most humans don't really do well with scary alphanumeric strings. At my age, I can't even remember maybe 2 or 3 IPv4 octets, never mind worldwide names. So symbolic naming, aliases, good plans. Automation, good plans. Yes, you can still use CLIs, but that's humans make typos. So think seriously about the automation side of this. And with that, I'm going to hand it over to Rupin.
Thank you, AJ. That was a great introduction. I'm going to talk to you guys about what are the different types of zones you can create in a Fibre Channel fabric. Fibre Channel really introduced the whole concept of shared storage. If you guys have been in the industry for long, direct attached storage is what was popular 25 years ago, right? Fibre Channel was built from the grounds up for really storage interconnectivity in a fabric. And that's why it's very popular, and customers continue to buy more Fibre Channel fabrics because they want to take advantage of shared storage and versus having these islands of storage attached to servers. So with that, the three types of zones that we can create and are most popular are single initiator based zones, peer zones, and target-driven zones, and then of course the switch port-based hard zoning that AJ talked about. So the first type, which is a single initiator-based zones, is actually very similar to how we used to connect, when we had direct attached storage on a SCSI bus, right? Where you had a single HPA, single adapter in the server connected to either several disks or even an external storage device that was storage array that was directly connected to the server. So single initiator based zones are very similar to that. Basically, you have one HPA port zoned with one target port. That way, the RSCN domains are very, very targeted. And, if there's something that's happening with the initiator or the target port, only the two devices are notified, and really there is no impact on the rest of the fabric. This is very popular because, that's how Fibre Channel began. And, the only downside to this particular type of zone is that you can end up in a large fabric. You can end up creating a lot of zones, because if you have a fabric with 10, 15, 100 servers, usually every server has two ports for multipathing. You can end up creating a lot of zones, and henceforth management of these zones, as well as there is a possibility of exceeding the zone database limits. As AJ pointed out, right, this is a very resilient service within the Fibre Channel fabric. Zoning databases are replicated across the fabric. So, this is a critical function, if, in a highly available enterprise storage network. This is a new type of zones that we came up in the FCIA and the T11 group, right? It's the peer zones and the target-driven peer zones. Peer zones were created, right, really to keep the concept of zoning, but try to reduce the number of zones that we have to create. So peer zones basically introduces a concept of something called a principal device, which is usually the target port on the storage array. You can include n number of initiators in the same peer zone. And the beauty about a peer zone is only the principal device can communicate with all the non-principal devices in the peer zone. In most cases, even the principal device cannot communicate with another principal device in the peer zone. So that way, you get all the benefits of single initiator zoning, yet you reduce the number of zones. An extension to this concept is what we call target-driven peer zones, where basically the storage array is responsible for all the creation and the management of all the peer zones in the fabric. The beauty of target-driven peer zones is that the storage array, while the customer is doing LUN masking, or in a more simplistic term, presenting these LUNs to particular servers, the zoning operation happens automatically. So the storage admins don't have to go and manage all these zones independently. And also it reduces basically one major step in storage orchestration. So when it comes to storage orchestration, TDPZ zones can really help automate that process. And the beauty about doing it in the protocol is that it happens at the lowermost of the foundational layer of the fabric. So the resiliency of the zoning engine built into the database is replicated all over the fabric. So everything is managed pretty seamlessly. And the third type of zone that I will talk about is called switch-based port zoning. Port zoning is very restrictive because you really have start creating zones based on ports in the switch, and if a device is moved to a different port, it can lose access to the particular target. And so henceforth, I mean, this type of zoning, very few customers end up using this type of zoning. Also keep in mind that um, when it comes to advanced storage features like peer persistence, some type of replication, etc., they generally do not support port-based zoning. So, my general recommendation to customers is, avoid port-based zoning. I really recommend target-driven and peer zones if customers, are interested. But legacy point of view, single initiator based zoning is what's most popular. But peer zones and target driven peer zones are gaining quite a bit of momentum. So with that, I will hand it over to Craig, who will dive more into the details about how zoning works. Thank you.
Thank you, Rupin. So I'm going to talk about how zoning works. So basically, from a high level, you can think of zoning like a privacy security wall. And this is done with a combination of hardware and software. So as has been mentioned previously, the most secure type of zoning is hard zoning. And the reason for this is that hard zoning is actually enforced by the hardware or the ASIC in the switches. This means that in the switch ports, there are a list of devices that are allowed access. And if that device is not in that list, access is simply denied. There's no way for that device to connect. This also has the advantage of having no performance impact because the hardware implementation runs at line rate, which means that enforcement of these zones does not slow down the traffic in the fabric. Now, though hardware details may vary by implementation, typically this is done via a hardware lookup table or a CAM within the switch ports. And so if a device is in that port, then access is allowed. If it's not, then it's not. Then access is not allowed. Of course, with all hardware, you need to have the software component as well. And the software component provides the interoperability. It holds the lists of zones, which in a zoning database, and it allows for the distribution of the zones throughout the fabric. And in Fibre Channel, the zoning database is a distributed database, which means that loss of one particular switch or component in the fabric will not bring down the entire fabric. The other switches have a complete view of the zoning database, and they can keep on operating. The other important thing is that the software interface is standardized. Zoning configurations and distribution, is defined in the T11 Fibre Channel standards, in particular in the FCSW and FCGS family of standards. And these standards have existed for more than a decade, meaning that there are multiple mini mature tested implementations out there. So the important piece of all this is the zone database. And the zone database contains everything you need to know about the zones. And the zone database is set up in a hierarchy, the highest being zone sets, which allows a grouping of zones, and then the zones themselves, which define the access lists and attributes. And then there's also aliases, which allows you to point in a more friendly fashion to zone members, as AJ talked about. And then there's the attributes. Each zone has a list of attributes which indicate the type of zones, the type of protocols allowed, so on and so forth. The zone set is actually a very important tool because it allows you to switch the configuration of a fabric pretty much on the fly. You can activate different zone sets for different configurations. For example, you could have one zone set for the normal daily operation, and you could have another zone set for your nighttime backups, which allows the backup server to access all devices, storage devices. So an example about setting up an activation of a zone. So if you start off your management station and you make a zoning change, that change is sent to your local attached switch, which then does a zone merge with the other switches in the fabric. Now this is important because this allows all switches to have a complete view of the zoning database, and the merge works by updating entries that don't exist in the local zoning database that may have come in from another switch. Now, of course, if you have if you have multiple devices changing a fabric at the same time, you could have inconsistent views. If you have two zones that come in of different members, that can actually result in an isolation. Isolation meaning that a switch is disconnected from the fabric. But there is a mechanism that exists to prevent this. The admin device can reserve the fabric for zoning changes so that you know that only one device is making changes at any one time. And this prevents the isolation and inconsistencies that could happen. So that's a little bit of a dive into how zoning works. And with that, I'll hand it over to Kiran.
Thank you, Craig. And so what we are now what we understand is basically what zoning is, how it works, and the basics behind it. I want to cover basically using zoning, putting it all together in the storage area network environments, and basically, like really, it's simple. It essentially partitions your network, make it more efficient, make it more or make it the performance of your network is more consistent if you zone it properly. And that actually is like really the first principle is keep it simple. And you can there are different kind of ways of keeping it simple. One zone per application, say for example, where your application needs access to all the storage, so that you can do. And that's where what Rupin was talking about, the peer zoning comes into play, right? Because your storage devices, you can actually start from there and say which servers need access to this device and limit the visibility into that. This is Zoning is not just for partitioning, but it actually what it achieves is the security of your data, because it basically limits the access to particular data sets for only to the servers that actually need it, right? And that actually is a very important function of a zoning that comes together through zoning, really. The all the vendors basically that work in Fibre Channel. So one of the best things about Fibre Channel is that the Fibre Channel Industry Association, um, and through T11, basically all the vendors come together to create the standards and then write their software uh, to meet those standards, basically. So once something becomes standardized, it proliferates pretty quickly through the industry. It creates the best practices around a use of a technology that is vendor agnostic. So it's basically very useful for customers to actually use it and get access to it. So many vendors, or almost all vendors, have some kind of automation and management solutions that actually allow you to automate the creation and management of zoning, basically. That achieves two things. One is so first is keep it simple, but with automation available, use automation where possible, because what that does is basically it saves you time, number one, and it avoids all the errors and debugging that's needed um, after the fact. And so it's basically reduces the management time, the management burden on the storage teams that are needed. So those are the like really basic ways you can manage, is like really keep it simple, use automation. And if you use automation, you'll basically, like, it'll be very simple and easy to manage for you guys. Um, the Another thing is basically, of course, regular maintenance. We all understand how the LUNs get created for projects. Projects finish, and the LUNs languish or whatnot. Same thing with servers. Servers come in, servers retire. Uh, all those activities that are happening around us. That means that you need regular maintenance. And again, this centralized management or automation through API, through CLI, whatever tools you want to use, those allow you to regularly maintain your zones. Um, Essentially, uh, the whole structure is such that in fiber channel, information propagates throughout the network um, uh, with with a lot of fabric services and general services that are available in the network, in the switches and in the HBAs and in servers and targets. So that actually allows you to like really make a change, and that propagates throughout the network properly, and you don't have to worry about dead weight, essentially, of having more zones that nobody's using, a lot of zones without members in it, and all that kind of thing. So keep an eye on it, and regular maintenance basically will help save a lot of cycles later on. So we're going to take a look at just a quick example of, like say, virtualization. Virtualization basically is pretty ubiquitous in data center environments, and Fibre Channel is the highest touch for virtualization. Basically, a lot of virtualization runs on Fibre Channel storage, and so one thing to do is basically ESX servers are all clustered, and every basically ESX server that is clustered needs access to the same storage for the cluster to work. And that means that you need zoning practices that might mean that it actually want to have more open zoning, but actually a little bit uh, counterintuitive, but you want to have more restrictive zoning practices in terms of clusters. So all ESX clusters are not, basically not every ESX server is used for the same function. Many times you will have some ESX servers reserved for one function versus the others, basically, right? So you can actually use that to lead your zoning practices. You can create zones that are like essentially divided by function, divided by applications that are being used. If you have, like, say, databases or SharePoint or whatnot, what other applications are running on certain clusters, limit the visibility to the volumes on to that cluster. What that'll automatically do is basically that'll limit your VM movement from across only those ESX servers. So basically, you have much more like segmented environment uh, where your storage team is actually assigning the storage to that particular set of servers, and those servers are running the VMs, and the VMs can move across those servers because they all have access to the same zone. Now, one thing to know is that the zone itself is actually on the WWN number of the HBA or the HBA port that is connecting, and like it was mentioned before, make sure you're using the right kind of zoning, basically either the peer zoning or the target-driven zoning, basically. But even if you use the switch-based zoning, it has the same kind of impact on the availability of the LUNs and all. But it depends on what you want to use. A WWN-based, worldwide name-based zoning is great. Another thing to note is that another thing, actually, one of the best practices would be that you want to WWNs are basically a string of hexadecimal numbers, basically. It's like about 8 of them in one name, and that's hard to remember. Nobody can remember, actually. And so using aliases is great, actually. Aliases basically create a easy to understand a name of your initiator server, whatever it is, right? So you can actually align your server names, initiator names, basically your server names, align your target LUN names, all that to your WWNs, worldwide names, basically, and then that allows you to like map it map it clearly, understand the mapping, see it through your centralized management console and all that. So that's what's what preferred. With virtualization and the newer NVMe devices, for example, it basically is exactly the same for what, even if you are using disks for some low level like or actually low importance workload, um, on not performance demanding workloads, to NVMe, which actually are very high performing devices. Zoning works exactly the same. Fibre Channel has been supporting NVMe since 1.0, even before 1.0, I would say, uh, since 3 generations back of Fibre Channel uh, network generations. So essentially, it's all baked in. We always have supported NVMe and SCSI, and all our technologies that go into SAN work the same way. Uh, uh, and so once you have set the zoning, that's another best practice, and this is what happens in typical data center environments is storage team is separate than virtual machine administration team or VMware administrators or even Microsoft administrators. There's nothing special about one or the other virtualization platform. uh, but zoning or actually having these in general Fibre Channel network administration separated out from virtual administrators, that allows you to basically hand over the control of actual VM administration without having to actually work very closely all the time. So it's basically, it provides you a very good way of actually keeping the control while actually allowing a lot of flexibility to the VM administrators. So zoning basically, because it limits the visibility to the data to only to those servers that need that information, all that you can actually manage through the limiting visibility feature of zoning. Again, centralized management, I cannot emphasize more, but it need not be a management console. It need not be a graphical console or anything like that. It can be an API. It can be some private cloud API like Puppet and Ansible that you're using. It's okay. It'll work. Many vendors support that. Support the CLIs and support their consoles, support those kind of structures. So you can actually use that very, very easily and incorporate that with zoning. Another example is databases. So basically, the same thing applies to databases. There is no vMotion or storage vMotion in databases, definitely, but there is basically a distributed database. There are database clusters that are actually important to make it work. And one of the major functions of databases is backup servers and tapes availability and all that. In those cases, basically creating separate zones for those actually helps in traffic shaping. Security is, of course, important for databases, but actually like more of backup and tape environments, basically. So you can create different zones for those, and then that way it'll be much faster to use. So that's essentially, zoning allows you a flexibility of creating a most efficient sub network within your larger network. And there are multiple ways of zoning. There are multiple ways you can automate it, and all are essentially supported because Fibre Channel standardizes a lot of this technology before this technology is commercially available, and that actually takes all the interoperability uh, or non-interoperability issues away from this, because when something is in the standard, everybody deploys to that standard, and actually that becomes very easy for customers to actually just buy it and use it, basically. So that's one of the best things about Fibre Channel. And with that, I'm going to just stop here and move over to the questions. Thank you for my co-presenters, but we'll go with the questions now. If you have any questions, please type those into the question uh, uh, question panel, and we'll take those up. as we can. If we can't answer those questions on the live call, we do post those online at FCIA website, and that information will be available uh, uh, in a day, perhaps a day or two after the webinar.
So
Great.
Right.
I'll take the first question, right? The target-driven zoning question.
Mhm.
Yes, please.
Okay, so yes, that is absolutely correct. The question is, if I understand this correctly, for target-driven zoning, the storage servers array must have explicit support in its software firmware. How widespread is this support at this point? That is correct. The storage array has to support target-driven peer zoning, as I mentioned in my section. This feature is built into the protocol. So basically, the target port on the storage array has to conform with the TDP-Z protocol. And yes, so henceforth, the firmware has to support it. The support is gaining traction. I mean, I work for Hewlett Packard Enterprise, so I can tell you that for HPE, our primary storage platforms support target-driven peer zoning.
If I could just add in on that, Rupin, for the folks that are on the line, please feel free to go push at your storage vendors, because if you look at this, right, the advantage that target-driven zoning gives you is they just make the normal configuration between the servers and the LUNs, or the servers and the namespace IDs that they would normally make, and let the array drive the zone configuration, and you don't even have to touch the switch, right? It's a really nice setup, and yeah, I'm a big proponent of it. If people can get it moving, yeah. Let me take the FICON question. So there's a question in mainframe FICON environments. We usually use hard zoning. The device's link address should not be changed. We usually have a zone with all ports in a logical switch, even if they're not currently in use. In the rare case of a device port failure, we can use port swap to move the link address, and the zone does not have to change. It is far too much work to set up aliases for worldwide names that do not move, often for 5 years, the length of the life of the box. Do you see the same? So I would have to say that in the FICON environment, and under cup management, yeah, I mean, chiplets don't get moved around a whole bunch, right? It's a pretty solid environment for long periods of time. So yeah, it's a much more static environment in that sense, hardware static environment in that sense than most of the open system side. So yeah, that's probably a true observation. I see a question on zoning merges. It used to be that all members in a zone had to be in the same order, or else a switch with its own zones could not merge. Has there been any standards update to fix this? So zone configurations are a fabric-wide environment, and I don't know, Craig, maybe you have some additional
Yeah, that's
thought on that.
the standard doesn't really talk about the order of elements in a zone. It really only talks about the members being the same. Now, this has to be exactly the same. All the names, every single detail has to be the same. The order is not important. So there's really no standard fix for that. I'm not sure about this particular issue. I don't know if it's a specific implementation issue, or if there might be an error in one of the zones. In particular, but realistically, you shouldn't have multiple zones coming in from different sources without one being created with a merge. So I'm really not sure about the problem this fixed, but the standard doesn't have any issue in this regard.
Yeah, from our standpoint, and I think it's true of all the switch platforms. If Kiran, if I get that wrong, kick me. But if somebody is collapsing multiple small zone islands into a larger zone fabric, if there are conflicts in the zone configuration, we'll segment. We won't allow that merge, right? Because you don't want to overwrite inadvertently, without purpose and forethought. You don't want to overwrite somebody's zone configuration. So yeah, the how the elements appear in the zone, as long as the as long as the component elements are all the same, and as long as the zone names match, right? So obviously, if you're going to merge it into a single fabric-wide configuration, zone names have to match. You can't have conflicts that way either. But we'll prevent the merge, and I believe that's true of everybody. We'll prevent the merge if there's a conflict.
It is. That part is basically pretty worked out already over the years, basically. So if I don't understand this to be an issue actually to fix, but I think if something is not matching, it cannot merge, and that's pretty standard. And then if it matches, it's fabric-wide zoning, so it basically works across the switches also. So it's basically switches are targets, right? So as long as it matches the WWNs and all that, or aliases, and then basically everybody will understand what it is and work basically. So that works. So there might be bugs there, I guess. I don't know. I don't understand that very well, the question, but today there is no conflict there. There's no way we can actually allow the conflicts to merge and then create issues basically. So that won't happen. All right, go ahead, Dan.
All right, seems like that's all our questions for today. So thank you to everyone for attending today, and special thanks to AJ, Rupin, Craig, and Kiran for such a great presentation. Before you leave, we ask that you please rate this event on a scale of 1 to 5. We do value your feedback. We will post a Q&A blog on the Fibre Channel FCIA website with answers to questions today. And we encourage you to follow us on Twitter at FCIA News for updates on future webcasts. And, this is just one of many webcasts that the FCIA has produced. And so we encourage you to go to the library on the fibrechannel.org website, where you'll see a wide range of Fibre Channel topics covered. Thanks again for attending. Have a great day.